A bullet of mass 20 grams is fired from a stationary rifle of mass 3 kg. Assume that the bullet moves horizontally. Immediately after firing, the rifle recoils. In other words, it moves back. Remember what we had in the multiple choice. It recoils with a velocity of 1.4 meters per second. Calculate the speed at which the bullet leaves the rifle. So this is about momentum. There is no way that we really cannot talk about the momentum. And remember, in terms of momentum, we are having the law of conservation of momentum, isn't it? And what does that say? It says the total momentum of an isolated system, or of objects in an isolated system, is equal to the total momentum of the objects in that particular system. Okay, so there should not be anything that is disturbing whatever situation is there. It must be in an isolated system, all right? And therefore, because of that, the total linear momentum before collision will be equal to the total linear momentum after collision. So we normally just use that sigma thing, and then P I is equal to sigma PF. And remember that this is total, and it's not for one object only, but for both, everything that is acting there. Okay, right? So since that before this leaves the rifle, they were both in one gun, so that's one rifle. So that's why we'll have to have them like that, because they are together. And we've got VI. Remember, that's initially, yeah, it's equal to. But after that recoiling, you find that one goes the other way, the other one goes the other way. So there is that separation now. So momentum, that's for V1, and then one initial. Final, yeah? Final, sorry. Initial is on the other side. And then M2, V2, still final, right? What happens to the first part? We are having there masses. We're having 20 grams. Guys, be careful. This is not chemistry. So we need to convert. And then this one is 3 is fine. But the 20 needs to be converted. And how do we convert? Use the King-Henry thing, eh? Right? We need to divide by 1,000. So if we have that, we are going to have 3 plus 0,02, not 002, yeah? Because this was 20. And then V initial, what is it? They were stationary, so that's going to be 0, right? Mass 1 is 3 multiplied by, now the problem. There's no way. You see, in terms of momentum, in terms of projectile motion, we always have to choose the direction. Okay, so let's say to the left. Let's say going this way is positive, all right? Right, and then M1, if it is 3, where was it going? From it, and assume that the bullet was immediately after firing requires with a velocity, okay, and then calculate the speed at which the bullet leaves the rifle. Okay, doesn't matter, we have chosen that one. If we take it as negative, then obviously we've got to check the other one, right? Let's take it as negative, and this is going to be minus 1,4, and then that's the velocity, isn't it? And then plus 0,02, and this is what you are looking for, if I'm not mistaken, eh? V2F or VF2, it doesn't matter the order really, but you have to be specific. So we know that everything that is multiplied by 0 will definitely still be 0, and that other one, when you do your calculations, 3 multiplied by 1.4, what do we get? 3 multiplied 1.4 is 4,2, minus 4 comma 2 plus 0 comma 02 V2F. Okay, so that, remember I said preferably let's keep things positive. 4 comma 2 is equal to 0 comma 02 V2F. All right, that makes the V2F to be equal to this. This is positive, eh? Remember this was negative, so when it comes that side it becomes positive. So 4 comma 2 divided by 0 comma 02. And what do we have? Right, divide by 0.02 to 10. And that's meters per second. All right, and look at the answer. The answer is positive, which means it is to the right. The other one was going to the left, whereas the other one will go to the right. Remember, when after recoiling, we know that they go the opposite direction. Okay, so please be careful of that. Direction will really make you to have wrong answers if you don't choose the right way. Eh? Okay, right, and then the bullet strikes a stationary 5 kg wooden block fixed to a flat horizontal table. The bullet is brought to rest after traveling a distance of 0.4 meters into the block. Refer to the diagram on the next slide. Let's have a look at what is happening. So there you go. That bullet, which was now released, comes there. It hits that block, and then thereafter it is inserted inside there.